This is our ICP 7 on regression. So first we imported our dependencies and libraries. We decided to use a wine quality data set that we got from the UCI repository. So this has 13 different attributes, I believe, and they're all numeric, which we can see here. There's float, 10 floats and one integer. And then also we can get the statistics from the data set. To decide what attributes correlate the best, we use the pair plot. So you can see here it plots every attribute against every other attribute. So if we pick one, we can see like density and total sulfur dioxide. They're somewhat correlated. And again, we can do that for many different things. So we decided to pick two of these attributes. So we chose alcohol and density, and we plotted them here to get a closer look. So we can see that there is a correlation between the two. As density increases, alcohol decreases. So it's a negative relationship. Here we split the data into testing and training data sets so we can get our metrics later on. And then we had to reshape the data so that it would fit into a scikit-learn linear regression object. We instantiated the object, fit the model, and then used it predicted on the X train, and then plotted those predictions as a red line. So you can see here that this red line is the predicted values. And, it correlates with the data. It's a decreasing slope. We can use the coefficient and intercept methods or calls to get the slope and intercept for this particular line. Finally, we can use the same regression to predict using our testing data. And then with that testing predictions, we can get our mean square error, mean absolute error, root mean square error, and R2 score. And for all of these, the value is pretty small. And that's because the slope is really small and there's a very fine precision within the data. You can see the scale on the y-axis. It's only by 0.1 each tick. And that's just the nature of the data set. And that's all.